Okay, so now we're on record. Welcome to this class. I have a little cold. It's been raining since morning. I'm hoping I'll be able to make it through the class. Now, before I proceed, I would like to find out if I'm audible. Can you hear me?
Yes, sir.
Yes, doctor. Annie.
That's
Yes, sir.
Yes, sir.
Yes, please.
okay. That's good. So today we are looking at deductive reasoning. Let me enlarge the screen. So welcome to the second half of the semester. Like I was saying before, the first half of this semester was a preparation where we were studying concepts in language and meaning. We studied statements that are not logical. You remember metaphors, proverbs, and all that. And then we learned to identify passages that are argumentative or not. Now it's time to study arguments. Different forms of reasoning. Arguments are also called reasoning or syllogisms. So these are three terms we use interchangeably. There are two major categories of reasoning. We have deductive and inductive. I mentioned it before. We also have causal reasoning, but it is a form of inductive reasoning. Now, deductive reasoning is also called deductive argument, deductive syllogism. Like I said, the three terms are used interchangeably: reasoning, argument, syllogism. Now, deductive reasoning is reasoning in which the relationship between the premises and the conclusion is a logical relationship. The relationship between the premises and the conclusion is a logical relationship. As a result of this, it is reasoning that permits only one conclusion. When you remember logical operations, what you remember is mathematics. When you are dealing with mathematics, you normally have only one conclusion. 2 plus 2 is 4. You can't have 2 plus 2 is 4 and another number. So that is how deductive reasoning is. So because of the logical relationship between the premises and the conclusion, it is a form of reasoning that permits only one conclusion. Example: all men are mortal. Kofi is a man, Kofi is mortal. Now, so if you say all men are mortal and you also said Kofi is a man, the conclusion that Kofi is mortal is inescapable. There's nothing you can do to change the conclusion. You cannot change or modify the conclusion to say Kofi is immortal or a fire cabinet is mortal. Before we begin dealing with this kind of argument, we need to make some clarifications and get educated on certain concepts we use in the argument. First of all, we have what we call the reference and attribute classes. The reference and attribute classes. Now, there are two parts of a sentence, like the subject and the predicate. That is, when we're dealing with arguments, we have two parts of the sentence. You remember in our English language class, we know about the subject and the predicate. In logic, we have the reference class, which is like the subject, and we have the attribute class, which is like the predicate. For example, all men are mortal. All men is the reference class. That's what we call the subject in English language. And then are mortal is the attribute class. That's what we call the predicate in English classes. Now, the reference class is that to which the sentence refers, whereas the attribute class is that part of the sentence that is attributing something to or saying something about the reference class. Then we have a distinction between finite and infinite reference classes. So now we are discussing reference class. We have two types. We have the finite and the infinite. So the reference class can be finite and infinite. The infinite reference class is a class that refers to all members or no members of a class. For the infinite reference class, it is either a class of all members or no members. It refers to all members or no members of a class, either 100% or 0. For example, all men, no man, any man. On the other hand, the finite reference class refers to countable or particular members of a class between 0 and 100%. Example, some men, 80% of men, 5 men, 1 man, all the men. Now remember that all the men is not the same as all men. All men is uncountable. All the men is countable. You can have all the men in this class. It is different from all men. When you say all men, you can't count them. Few men, of course, few men are countable. Almost all the men, that's countable. So these are countable terms. Now the infinite reference class refers to uncountable members of a class, all men or no men. But the finite reference class refers to countable or particular members. So between 0 and 100%. Because of that, we have a distinction between the universal and particular statements. Statements containing infinite reference class are called universal statements, whilst those containing finite reference classes are called particular statements. Example of universal statements, that is those containing infinite reference class, all men are mortal. Example of particular statements, some men are mortal, or some men drink alcohol. A little exercise. Which statements are universal and which are particular? This table is three-legged. Tables can be sat on. So I think I should just answer them. This table is three-legged, it's particular. Tables can be sat on is universal. You can't count it because it's an uncountable reference class. James and Mary passed the examination is a particular statement. There are 2 people involved. So it's countable. All visitors should be treated with respect. It's a general statement because the sentence contains an infinite reference class, a class of uncountable members. Now let's talk about validity. An argument is valid if the premises make the conclusion necessary and the conclusion follows with certainty. If the premises make the conclusion necessary and the conclusion follows with certainty, then an argument is valid. All valid arguments are deductive arguments. So inductive arguments are strictly not valid. Deductive argument is a purely mathematical argument. The relationship between the premises and the conclusion is logical. So you remember the example I just gave. Let's compare it to an inductive argument. This is an example of an inductive argument. Premise 1, 95% of men are honest. Peter is a man. Therefore, Peter is honest. When you look at this argument, you see that more than one conclusion is possible. Now, if you say 95% of men are honest and Peter is a man, the conclusion that Peter is honest is not the only possible conclusion. Now, if Peter is among the 95% of men that are honest, then the conclusion is true. But if Peter happens to be among the 5% of men that are dishonest, then the conclusion is not true. So there are 2 possible conclusions. Possible conclusion 1, Peter is honest. Possible conclusion 2, Peter is not honest. That is how you know an inductive argument. An inductive argument is an argument that permits you to have more than one conclusion. And I think that's for me, that's the primary way of detecting whether an argument is inductive. If it is an argument that permits only one conclusion, then it's a deductive argument. Now let's look at the hidden condition, if and then. All arguments have hidden conditionals. Now, look at this categorical statement. All men are mortal. If we are to convert this statement, categorical statement, to a conditional statement, how would it read? It will read something like this. If something is a man, then it is mortal. So look at the categorical statement, all men are mortal. As a conditional statement, if something is a man, then it is mortal. So you need to learn to convert categorical statements into conditional statements. I'm giving you that as an assignment because it's very important in logic. Now change the categorical statement of premise 1 to a conditional statement. So if something is a man, then it is mortal. Peter is a man. Therefore, Peter is mortal. So you see our original argument, all men are mortal, Peter is a man, Peter is mortal. Now we've changed premise 1 from a categorical statement, all men are mortal, to a conditional statement. If something is a man, then it is mortal. And then premise 2 and the conclusion follow. Changing a categorical statement to a conditional statement for premise 1 helps you to see an argument more clearly. Yeah, so in this form, with premise 1 as a conditional statement, you see how the argument flows. Now let's replace with symbols. Categorical version, all men are mortal. All A's are B's. Peter is a man, X is an A. Peter is mortal, X is a B. All A's are B's, X is an A, X is a B. Now, the symbol A is used to represent men. The symbol B is used to represent mortal. And then we find another symbol for Peter, which is X. So all A's are B's, X is an A, X is a B. When you look at the symbolic version of this argument, you'll see that X is an A, X is a B. It is a kind of operation where you identify X with the first symbol and then you identify X with the second symbol. X is an A and then X is a B. So X identifies with 1 with A and then X identifies with B. You know, it's like a kind of do me, I do you. You do to, if you do to Peter, you also do to Paul. You know. So that's basically, in mathematical form, that's how you see how an argument proceeds. Now let's look at the conditional version. If something is a man, then it is mortal. Peter is a man, Peter is mortal. If A, then B. A, therefore B. If A, then B. X is an A, therefore X is a B. You see that? Now it should be clearer to you. If A, then B. X is an A, therefore X is a B. If A, then B. A, therefore B. For the second and third statements, you can see that you can afford to put X's or you can remove X's. It's still the same thing. Now let's look at antecedents and consequences. Now let's remember what we just did on the reference class and the attribute class. If we restate any categorical proposition as a conditional statement, let's assume we convert a categorical to a conditional statement. The reference class becomes the antecedent and the attribute class becomes the consequent. So for example, all A are B is a categorical statement. Then for the conditional version, if A, then B. To convert it to conditional, if A, then B. The reference class, in this case A, is the antecedent. And the attribute class in this case is the consequent. So A is the antecedent and B is the consequent. So whenever you are making a statement, just remember that the first part is the antecedent, the second part is the consequent. When you convert it to a conditional statement, the part of the sentence, which is its first part, it is also the part that starts with if, is the antecedent. Then the other part, the second part of the sentence, which is the part that starts with then, is the consequent. So any statement referring to A will be either affirming or denying the antecedent. So if you say, for instance, X is an A, that is a statement that affirms the antecedent. Any statement referring to A will be either affirming or denying the antecedent. And any statement referring to B will be either affirming or denying the consequent. So for instance, when you go, let's go back. You see this, the symbolization of the argument. All A's are B's, X is an A, X is a B. We're saying that all A's are B's is a categorical statement. Normally, the first part, which is A's, is the antecedent. The second part, which is the B, is the consequent. If you convert it to a conditional statement, you see it clearly. If A, then B. So the part that starts with if is the antecedent.
Sir,
Yes?
please, you're moving too fast.
No, I don't think so. You are not worse than all the other students over the years. I think I'm rather too slow. I'm patient so that you understand it. So all A's are B's. The first part is the antecedent, the second part is the consequent. So X is an A is a statement that refers to the antecedent. X is a B is a statement that refers to the consequent. Okay, so that's what I want you to understand. Any statement referring to A is referring to the antecedent. Any statement referring to B is referring to the consequent. Now, a statement referring to the antecedent is either affirming or denying it. X is an A affirms. But any statement referring to B is either affirming or denying it. X is a B affirms. If it is X is not an A, then it denies the antecedent. If it is X is not a B, then it's a statement denying the consequent. Okay. So now let's go back to where we were. So any statement referring to A will be either affirming or denying the antecedent, and any statement referring to B will be either affirming or denying the consequent. Okay, so example, X is an A, affirms the antecedent. X is not an A, denies the antecedent. X is a B, affirms the consequent. X is not a B, denies the consequent. All right, so affirming the antecedent. All A's are B's, X is an A, therefore X is a B. Now, when you look at this argument, we say it is, you will see that the second statement, X is an A, is affirming the antecedent. Now, because the second statement, or you say the second premise, is affirming the antecedent of the first premise, we say that the whole argument is affirming the antecedent. Or you say it is an argument that affirms the antecedent. Now let's look at this one. Denying the antecedent. All A's are B's. X is not an A, X is not a B. Now, because the second premise is denying the antecedent, we say the whole argument is denying the antecedent. This is an argument that denies the antecedent. And then affirming the consequent. All A's are B's, X is a B, therefore X is an A. Now, because the second premise is affirming the consequent, we say the whole argument affirms the consequent, or it is an argument that affirms the consequent. And then denying the consequent. All A's are B's, X is not a B, therefore X is not an A. Now, because the second premise is denying the consequent. We'll say the whole argument is denying the consequent, or it is an argument that denies the consequent. Now, the rule for deductive reasoning. So now this is the rule for deductive reasoning. We only affirm the antecedent or deny the consequent in order to reach a valid conclusion. We only affirm the antecedent or deny the consequent in order to reach a valid conclusion. So out of the 4 arguments we just saw, only 2 of them are valid. The one that affirms the antecedent, all A's are B's, X is an A, therefore X is a B. And then the one that denies the consequent, all A's are B's, X is not a B, therefore X is not an A. Only those 2 arguments are valid. The other 2 are not valid. So all A's are B's, X is not an A, therefore X is not a B. It denies the antecedent. It is not valid. It's a fallacy. And then the other one that affirms the consequent, all A's are B's, X is a B, therefore X is an A, denying the consequent, affirming the consequent, that one is not valid. So let's go back. The argument that affirms the antecedent, all A's are B's, X is an A, therefore X is a B. This argument is valid according to the rule. Very soon we'll see why it is valid. Denying the antecedent, all A's are B's, X is not an A, therefore X is not a B. This argument is not valid. We'll see why it is not valid. Affirming the consequent, all A's are B's, X is a B, X is an A. This argument is not valid. It affirms the consequent, so it's not valid. It is only the one that denies the consequent that is valid. And then denying the consequent, all A's are B's, X is not an A, therefore X is not a B. This is a valid argument because it denies the consequent. So we only affirm the antecedent and deny the consequent in order to reach a valid conclusion. Any other operation would make the argument lose its validity. So this is an example. I didn't know this example is here. That is why we went back. So all A's are B's, X is not
I filled it. Is it?
Let me see. Blessing, can you mute your mic? Okay. So all A's are B's, X is an A, affirms the antecedent, X is a B, is a valid argument. All A's are B's, X is not an A, denies the antecedent, X is not a B, is not a valid argument. Now let's convert it to words. All Ghanaians are Africans. Peter is a Ghanaian, affirms the antecedent. Peter is an African, is a valid argument. Now all Ghanaians are Africans. Peter is not a Ghanaian, denies the antecedent. Peter is not an African, is not a valid argument. Okay. Now, what is the technicality? Why is one correct and the other one is not correct? The consequent is always a larger class of denotations or members compared to the antecedent. So the consequent contains the denotations of both the antecedent and possibly more. When you check the 2 classes, the antecedent class and the consequent class, or when you check the class of the antecedent and the class of the consequent, the class containing the consequent is normally bigger than the class containing the antecedent. The consequent class can contain the antecedent class, the whole of the antecedent class, and then also contain more. That is the rule. That's how it is naturally. That is nature. We'll see why it is so. Now, the consequent, Africans, contains more members than the antecedent Ghanaians. When you say all Ghanaians are Africans, you are implying that Africans is a bigger class than Ghanaians and can contain more than Ghanaians. But you cannot imply that the class Ghanaians is bigger than the class Africans. So when you deny something of membership in a smaller class, you have not denied it of membership in the larger class. So when you say all Ghanaians are Africans, it means that anyone who is a Ghanaian is an African. Now, because we said the class of Africans is bigger than the class of Ghanaians, if you say someone is not a Ghanaian, you can't automatically say he's not an African, because Africa is bigger than Ghana. Denying someone of being a Ghanaian doesn't necessarily mean denying him of being an African. But when you deny something of membership in a larger class containing all the members of a smaller class, you have automatically denied it of membership in a smaller class. So if you say all Ghanaians are Africans, and you say Peter is not an African, automatically he's not a Ghanaian, because you said all Ghanaians are Africans. So that's why we say deny something of membership in a larger class containing all the members of a smaller class, you have automatically denied it of membership in a smaller class. Okay, so this is the technicality you need to understand. When class A is part of class B, and class B is bigger than class A, it means that anything in class A is automatically in class B. Anything that is not in A might still be in B, because B is bigger than A. B contains other things apart from A. Now, when you say the Department of Economics is in the University of Ghana, you are implying that the University of Ghana is bigger than the Department of Economics. So anyone who is in the Department of Economics is automatically in the University of Ghana. Now, if you say someone is in the Department of Economics, automatically you're saying he's in the University of Ghana, because everything in the Department of Economics is everyone in the Department of Economics is in the University of Ghana. Now, if you say someone is not in the Department of Economics, you have not automatically denied her of membership in the University of Ghana, because University of Ghana is bigger than the Department of Economics. So if you say Peter is not in the Department of Economics, you can't say, therefore, Peter is not in the University of Ghana. That's a fallacy. It's not a valid operation. So I'm trying to explain that the consequent is usually a bigger class compared to the antecedent. Okay. So now, based on that explanation, let's look at 4 kinds of deductive arguments. We have modus ponens, which is an argument that affirms the antecedent. So any argument that affirms the antecedent, we call it a modus ponens. All A's are B's, X is an A, X is a B. Or all Ghanaians are Africans, Peter is a Ghanaian, Peter is an African. So this is an argument that affirms the antecedent. Now, let's look at the fallacy of modus ponens, or rather the fallacy of denying the antecedent. All A's are B's, X is not an A, X is not a B. All Ghanaians are Africans. Peter is not a Ghanaian. That denies the antecedent. Therefore, Peter is not an African. This is not a valid argument, because Peter could possibly be a Cameroonian. Okay, so that is why an argument that denies the antecedent is not a valid argument. Now let's look at the sizes of antecedent and consequent. So like I said, the consequent is a bigger class compared to the antecedent. everything in the antecedent is logically in the consequent, but not everything in the consequent is equivalent to the antecedent. So the antecedent is usually logically smaller than the consequent. Now, if you say that something is part of the antecedent, it means such a thing is automatically in the consequent. But if you say that something is not in the antecedent, you have not automatically denied it of membership in the consequent, because it could be in any part of the consequent that is outside the antecedent. So affirming something of membership in the antecedent in order to affirm it of membership in the consequent is a successful logical operation. But denying something of membership in the antecedent in order to deny it of membership in the consequent is not a valid operation. It's not a successful logical operation. So let's look at the two boxes. We said all Ghanaians are Africans. So Africans should be a larger class compared to Ghanaians. So because of that, if you identify someone as a Ghanaian, and then on the basis of that conclude that the person is an African, you are correct, and it is a valid argument. After all, anyone who is a Ghanaian is an African. But if you say someone is not a Ghanaian, and on the basis of that, you say he's not an African, that is an invalid logical operation, and we call it a fallacy. Because denying someone, saying that someone is not a Ghanaian in order to say he's not an African is not true. The person could be in another country in Africa. Okay, so that is why we said only an argument that affirms the antecedent in order to affirm the consequent is correct. An argument that denies the antecedent in order to deny the consequent cannot be correct. And then if you say that someone is an African, and on the basis of being an African, conclude that the person is a Ghanaian, that's an invalid operation. You cannot conclude that someone is a Ghanaian by saying that he's an African. So any argument that affirms the consequent in order to affirm the antecedent cannot be correct. Saying that someone is an African is not a guarantee that the person is a Ghanaian. The person could be a Cameroonian or a Togolese. So an argument that affirms the consequent in order to reach a conclusion about the antecedent is not correct. Any argument that says X is a B, therefore X is an A, is not correct. But if you say that someone is not an African, and on the basis of that, you conclude that the person is not a Ghanaian, you are correct. Because if you deny someone of being an African, automatically you have denied him of being a Ghanaian. Denying anything of membership in the larger box automatically denies it of membership in the smaller box. That is why we say that an argument that denies the consequent in order to deny the antecedent is a valid argument. It is correct. So any argument that says X is not a B, therefore X is not an A, is correct. So it is only an argument that affirms the antecedent. X is A, therefore X is B, is correct. And then the one that says X is not a B, therefore X is not an A, is correct. Only two operations are valid. Either an argument affirming the antecedent or an argument denying the consequent. Okay, so let's look at modus tollens. Modus tollens is an argument that denies the consequent. Precious Aram, why is your microphone on? Okay, modus tollens. All A are B. X is not a B, therefore X is not an A. So this is an argument that denies the consequent. If A, then B. That's the conditional version. If A, then B. Not B, therefore not A. So this is the conditional version. So let's translate it into words. All Ghanaians are Africans. Michael is not an African, therefore Michael is not a Ghanaian. So it is an argument that denies the consequent. Or if Michael is a Ghanaian, then he's an African. Michael is not an African, therefore Michael is not a Ghanaian. So this is an argument that denies the consequent, and we said it is correct. If you deny something of membership in the consequent, you have automatically denied it of membership in the antecedent. So let's say all those studying in the Department of Physics are enrolled at the University of Ghana. Kelvin is not enrolled at the University of Ghana, so Kelvin is not studying in the Department of Physics. Let's assume that we are debating whether one of our colleagues is, or let's assume we are debating whether someone called Kelvin is in the Department of Physics at the University of Ghana. There is a debate about that, about his membership of the Department of Physics at the University of Ghana. And then someone goes to the registry to find out if he's enrolled at the University of Ghana. And then the registrar tells the person that Kelvin is not enrolled at the University of Ghana. Automatically, that settles the debate about whether he's in the Department of Physics. If he's not enrolled at the University of Ghana, then he's not in the Department of Physics. That is an argument of denying the consequence. All those studying in the Department of Physics are enrolled at the University of Ghana. Kelvin is not enrolled at the University of Ghana. So that denies the consequence. So Kelvin is not studying in the Department of Physics. So this is the map. You have Department of Physics in the University of Ghana. If you are not in the University of Ghana, you cannot be in the Department of Physics. But if you are not in the Department of Physics, it is still possible that you are in the University of Ghana because there are other departments. Now, so the fallacy of affirming the consequent. All A are B. X is a B, X is an A. Or if A, then B, B, therefore A. Now in words, all Ghanaians are Africans. George is an African, therefore George is a Ghanaian. Now, so this is an argument that affirms the consequence, and it is a fallacy. You can't say that someone is a Ghanaian just because he's an African. So affirming the consequent is incorrect, or rather is invalid. So the consequent Africans contains a logically larger category of denotations compared to the antecedent Ghanaians. So the fact that George is an African does not necessarily mean that he's a Ghanaian. He may be a South African or a Cameroonian. If we affirm the consequent, we are not sure we can affirm the antecedent. In short, if we affirm the consequent, it will land us in the same kind of uncertainty that we saw in the fallacy of modus ponens, that is, in the fallacy that denies the antecedent. Another form of the fallacy of modus tollens. All A are not B. All A are not B. X is not a B, therefore X is an A. Now remember that two negatives gives you one positive. So all A are not B, X is not a B. It's like saying all A are B, X is a B. So it is an argument that affirms the consequent. It's not an argument that denies the consequent, because the two statements amount to a positive. Okay, so in words, All human beings are not goats. X is not a goat. X is a human being. So the first and the second statement are negatives. Therefore, the second statement affirms the first one. So it is an argument that affirms the consequent. If you are a human being, then you are not a goat. You are not a goat, therefore you are a human being. But we have said that any argument that affirms the consequent is not a valid argument. You can only reach a valid argument by denying the consequence. So again, not being a goat is a logically larger category than all human beings. So the fact that X is not a goat does not necessarily make X a human being. X could as well be a cat or a tiger. Now, so we are done with modus ponens and modus tollens. The third kind of deductive reasoning is hypothetical syllogism. Now let's look at how it proceeds. This is an argument where the consequent of an initial or first premise becomes the antecedent of a second or subsequent premise. So we're saying that when you see an argument and you notice that the consequent of the first premise has become the antecedent of the second one, and then even the consequent of the second one also becomes the antecedent of the third one, and it just continues like that. And the subsequent premises feature the consequence of their predecessors as their antecedents. And then the conclusion pairs the very first antecedent with the very last consequent. For example, all A are B, all B are C, therefore all A are C. Now you will notice that the consequent of the first premise has become the antecedent of the second premise. And then the conclusion brings together the first antecedent and the last consequent. So the first antecedent is A and the last consequent is C. So the conclusion just brings together the first antecedent and the last consequent. Now all A are B, all B are C, therefore all A are C. You can extend it. You can say all A are B, all B are C, all C are D, all D are E, all E are F, and you continue down to Z. And then you say, therefore all A are Z. So the mechanism of this argument is that the consequent of a premise becomes the antecedent of the next premise. And at the end of the argument, the conclusion will just bring together the very first antecedent and the very last premise. Look at the conditional version. If A, then B. If B, then C. Therefore, if A, then C. If A, then B. If B, then C. Therefore, if A, then C. Let's put it in words. All Ghanaians are Africans. All Africans are human beings. Therefore, all Ghanaians are human beings. If you are a Ghanaian, then you're an African. If you're an African, then you're a human being. Therefore, if you are a Ghanaian, then you are a human being. So that's a hypothetical argument or a hypothetical syllogism. So we notice that the consequent of the first premise, which is B, becomes the antecedent of the second premise. And then the antecedent of the second premise, which was the consequent of the first premise, leads us to a new party, which is C, as the consequent. So any additional subsequent premise will just be featuring the consequence of its predecessor as its antecedent. Now let's look at two fallacies of hypothetical syllogism. So we are trying to see how not to write a hypothetical syllogism. The first fallacy, all A are B, all B are C, therefore all C are A. So this is a fallacy. let's put it in words. All Ghanaians are Africans. All Africans are human beings. Therefore, all human beings are Ghanaians. So this is a fallacy of hypothetical syllogism. The conclusion is reversing what should be the antecedent and what should be the consequent. Instead of, therefore, all Ghanaians are human beings, it is saying all human beings are Ghanaians. Okay, so that's the first fallacy of hypothetical syllogism. All A are B, all B are C, therefore all C are A. That's a fallacy. Now let's look at the second hypothetical fallacy. All A are C, all B are C, therefore all A are B. Now let's put it in words, but let me repeat it. All A are C. Instead of all A are B, you just went to all A are C, and then all B are C, therefore all A are B. So you are trying to identify A with B because both of them are C. Now let's put it in words. All Ghanaians are Africans. All Kenyans are Africans. Therefore, all Ghanaians are Kenyans. Now, so it is a fallacy because the fact that you identified Ghanaians as Africans and also Kenyans as Africans doesn't say anything about the relationship between Ghanaians and Kenyans. So identifying two parties with a third party does not tell you anything about the original two parties. That both of them belong to a third party does not say anything about whether both of them are the same or whether both of them have any relationship. So that's why we said all A are C, all B are C, therefore all A are B is invalid, is a fallacy. Okay, so sometimes it can be true by accident, but you need to recognize that anytime it happens to be true, then it was true by accident. All Ghanaians are human beings. All Africans are human beings. Therefore, all Ghanaians are Africans. Now, this is true by accident, but it doesn't mean that it is a valid operation. The fact that Ghanaians are human beings and Africans are human beings is not the reason why you knew that Ghanaians are Africans. You knew that Ghanaians are Africans on the basis of information that is not in the first two premises or the first two statements. So normally an argument should provide you all the information you need for the conclusion in the premises. Now, so we said that this kind of argument is normally a fallacy. All A are C, all A are C, all B are C, therefore all A are B. It's a hypothetical fallacy. It's the second hypothetical fallacy. Then the fourth kind of deductive argument. We've seen modus ponens, we've seen modus tollens, we've seen hypothetical syllogism. Now we're seeing the last one, disjunctive syllogism. This is a syllogism where the main premise is a disjunctive, either or. The main premise is a disjunctive, either or. When we affirm something of any of the disjunctive items, then we have automatically denied it of the other disjunctive part. Example, either A is true or B is true. A is true, so B is false. So this is the disjunctive argument. In this argument, the first premise is what we call a disjunct. It's an either or statement, either this or that. So either A is true or B is true. A is true, so B is false. Let's put it in words. Either I became a reverend father or I got married. I got married, so I did not become a reverend father. So that's the nature of a disjunctive argument. Owusu Arnold Kofi. Why is your microphone on? Now, a little exercise. Determine which kind of argument this is. Anytime he goes to town, he passes by my mother's house. That's premise one. Today, he passed by my mother's house, so he went to town. What kind of argument is this? Is this a modus ponens, an argument that affirms the antecedent? Or is it a modus tollens, an argument that denies the consequent? Or is it a hypothetical syllogism? Or is it a disjunctive syllogism? Anyone with any ideas? Okay, so this is an argument that denies the antecedent. Anytime he goes to town, he passes by my mother's house. Now, I have said that the first part of the premise one is normally the antecedent. So anytime he goes to town is the antecedent. He passes by my mother's house is the consequent. Now, the second premise says, today he passed by my mother's house. So this is a premise that affirms the consequent. Today he passed by my mother's house. So an argument that affirms the consequent is a fallacy of modus tollens. So this is a fallacy of modus tollens. Now let's look at this brief exercise. We deduce correctly when we deny the antecedent, true or false. We had said it is, sorry. We deduce correctly when we deny the antecedent. We had said it is false. When you deny the antecedent, you don't deduce correctly. We deduce correctly when we affirm the antecedent. That is true. We deduce correctly when we deny the consequent. That is true. We deduce correctly when we affirm the consequence. That is false. Now let's look at validity versus soundness. Now earlier I had said that only deductive arguments are valid arguments. That is correct deductive arguments. Now the 4 types of deductive syllogism are 4 ways of making deductively valid arguments. Yeah, sorry for that. So the 4 types of deductive syllogism are 4 ways of making deductively valid arguments. A valid argument is an argument whose premises are logically consistent with its conclusion. The premises of a valid argument necessarily imply its conclusion in the manner that it is impossible to deny the inference without running into self-contradiction. Now, an invalid argument is an argument whose premises do not logically imply the conclusion. So we saw that an argument that denies the antecedent in order to reach a negative conclusion about the consequent is not a valid argument. So it is an example of an invalid argument. Now, the relationship between the premises and the conclusion is not that of logical necessity. You could proceed to deny the conclusion of an invalid argument without contradicting yourself. So an argument that denies the antecedent is not a valid logical operation. And it is not valid because you can proceed to deny the conclusion of that argument without contradicting yourself. Now, when you say that Peter is not a Ghanaian, and on the basis of that, you conclude that he's not an African, that's an argument that denies the antecedent. That argument is not valid because you can proceed to deny it without contradicting yourself. You can say, no, Peter is not a Ghanaian, but Peter is an African. And you have not contradicted yourself because Peter could come from another African country. So when someone makes an invalid deductive argument, such as an argument that denies the antecedent, Peter is not a Ghanaian, therefore Peter is not an African, you can deny that argument without contradicting yourself. That is why the argument is invalid. Any argument that can be attacked, any argument that can be opposed without contradiction is invalid. So an argument that denies the antecedent is invalid. Another argument that affirms the consequent is invalid. Trying to show that Peter is a Ghanaian just because he's an African is invalid. You can oppose it without contradicting yourself. If someone says Peter is an African, therefore Peter is a Ghanaian, an argument that affirms the consequent, the argument is invalid because you can attack it without contradicting yourself. You can say, oh, you said Peter is an African, therefore he's a Ghanaian. No, I disagree with it. Yes, Peter is an African, but he's not a Ghanaian. And you are also not wrong because Peter could come from another African country. So anyone can oppose an argument that affirms the consequent without self-contradiction. Therefore, an argument that affirms the consequent is not a valid argument. So those arguments that are invalid, we call them formal fallacies. So the argument that denies the antecedent is a formal fallacy. The argument that affirms the consequent is a formal fallacy. Now let's look at this. An argument can be valid, but it is not sound. So we said there are only two valid arguments, the one that affirms the antecedent and the one that denies the consequent. Now let's look at this. All human beings are immortal. Peter is a human being. Therefore, Peter is immortal. So this is a valid argument because it affirms the antecedent. But the fact that it is valid doesn't mean that it is true. You can insert incorrect information in a valid argument. It will still be valid because the relationship is correct, but it is not saying the truth. Now, this argument is valid because it affirms the antecedent. All human beings are immortal. Peter is a human being, therefore Peter is immortal. It's a valid modus ponens. But is it a true argument? It is not true because one of the premises contain incorrect information. All human beings are immortal is incorrect. And that affected the conclusion. Peter is immortal. So this is a valid argument, but it is not a true argument. An argument that is valid, but it is not true, is not a sound argument. For an argument to be sound, it has to be valid, and it also has to be true. So if you change the immortal to mortal, you say all human beings are mortal, Peter is a human being, therefore Peter is mortal. That is a valid argument, and it is also true. So we say it is a sound argument. Soundness needs both validity and truth. Now, so we say this argument is valid because it is a correct modus ponens, but it is not sound because one of the premises is not true. Now let's look at other examples. All men are mammals. All mammals must get killed. Therefore, all men must get killed. Now, this is what? First of all, what kind of argument is this? All men are mammals. All mammals must get killed. Therefore, all men must get killed. All A are B. All B are C. Therefore, all A are C. That's a hypothetical syllogism. Now, but is it true that all men must get killed? It is not. So there is an incorrect information somewhere, and it is in premise 2. All mammals must get killed. And that affected the conclusion, all men must get killed. So in order to correct the conclusion, you have to go and correct premise 2. All mammals must get killed. So it is a valid hypothetical syllogism, but it is not a true argument. So the argument is not sound. It is valid, but not sound. Now, we can have invalid argument with a true conclusion. Democracy is better than other forms of political organization because citizens in a democracy are holier than citizens in another form of political organization. Now, the premise is the conclusion is the first part of the sentence. Democracy is better than other forms of political organization. That's the conclusion. And then the premise is because citizens in a democracy are holier than citizens in another form of political organization. Now, if you look at this argument, you will see that the conclusion is actually true. Or at least we regard the conclusion as true. Democracy is better than other forms of political organization. That is true. But does that make the argument correct? Because citizens in a democracy are holier than citizens in another form of political organization. We don't agree with that. So this is an invalid argument with a true conclusion. True conclusion alone does not make an invalid argument correct. So the argument is invalid, but the conclusion happens to be true. So the argument is not sound. So we have valid argument, we have valid and sound argument. To be sound, all the premises in a valid argument must be true. All men are mortal. Peter is a man, Peter is mortal. So a valid argument that is also true is a sound argument. So we have three forms. We have valid and sound. We have valid and unsound. Now, valid and sound is when the argument is valid and the information in the argument is also true. Then we have valid and unsound. Valid and unsound is the argument is valid. That's the relationship between the premises and the conclusion is correct. But the information in the argument is false. So it is valid and unsound. Then we have invalid and unsound. Now, let's see, we just saw a valid argument that is also sound. All men are mortal, Peter is mortal, Peter is a man, therefore Peter is mortal. Now let's look at this one, valid and sound. All snakes are reptiles. Cobra is a snake, therefore cobra is a reptile. Cobra is a snake. That's a premise that affirms the antecedent. So this is an argument that affirms the antecedent. It is a valid modus ponens. So because it's a valid modus ponens, it is a valid argument. And then what about the information in the argument? All snakes are reptiles is correct. Cobra is a snake is correct. Therefore, cobra is a reptile. So it is a valid and sound argument. Now we said it is valid because it is a correct rule for deductive reasoning, affirming the antecedent. And it is true because all the premises are true. Valid but unsound. All snakes are reptiles is correct. Mosquitoes are snakes is wrong. Therefore, mosquitoes are reptiles. Now, this is an argument that affirms the antecedent. It's a valid modus ponens. But the information in the argument is not correct. So although it's a valid modus ponens, the argument is not true. So we say it is valid but unsound. The argument is valid because a correct rule of deductive reasoning affirming the antecedent, but it's unsound because one of the premises is not true. Both invalid and unsound. All snakes are reptiles. mosquitoes are reptiles. Therefore, mosquitoes are snakes. Now, mosquitoes are reptiles. That's a premise that affirms the consequent. Remember that reptiles is the consequent. So mosquitoes are reptiles affirms the consequent. So this is an argument that affirms the consequent, which is a fallacy. It's a fallacy of modus tollens. So first of all, it is not a valid argument because it's a fallacy. And secondly, the information in the argument is not correct. Mosquitoes are reptiles is not correct. So the argument is both invalid and unsound. Okay. The last sentence. Invalid because the argument affirms the consequent. Unsound because one of the premises is not true. Now, is an invalid but sound argument possible? No. An invalid argument is already unsound, even if the premises and the conclusion are all true. All Ghanaians are Africans. Kofi is an African, therefore Kofi is a Ghanaian. So it is an invalid. Any argument that is invalid is already unsound. So soundness needs both validity and truth. So validity is needed for soundness, but soundness is not needed for validity. Something can be valid and it's not sound. Some arguments are valid but not true. Soundness needs both validity and truth. Now a little exercise. Identify the missing premise in each of the following deductive arguments. Now this is a simple exercise that don't even depend on our class on deductive reasoning. All military men play football. Bob plays football. What is the third statement in the argument? All military men play football.
Bob is a military man.
Bob plays football. There's a third statement that is supposed to make it an argument.
Bob is a military man.
Bob is a military man. That's fine. All Americans are human beings. All Americans are human beings. All Americans are mammals. There's a third statement.
Human beings are mammals.
All Americans are human beings. All Americans
Human beings
are
are mammals.
Human beings are mammals.
all human beings are mammals. That's correct. Okay, so that's it. Answer correctly. Which fallacy is committed by the following? All A's are C's. All B's are C's. All A's are B's. All A's are C's, all B's are C's, all A's.
Hypothetical syllogism.
Yeah, that's a fallacy of hypothetical syllogism or a hypothetical fallacy. All right, we were saying that all Ghanaians are Africans, all Kenyans are Africans, therefore all Ghanaians are Kenyans. All right. Describe the following arguments. All Europeans are not my friends. Ben is not a European, therefore Ben is my friend. Remember, we said that two negatives amount to a positive. So you can as well eliminate the two negatives and then just read them as positives. All Europeans are my friends. Ben is a European.
All Europeans are my friends. Ben is European. All Europeans are not my friends. Ben is not an European. Ben is my friend.
Look at the one below. No European is my friend. Ben is not a European. So it's another version of the first one. So the first statement, you have no European. The second statement, you have not a European. So these two statements contain negative European. So not no European, not a European. If you eliminate the two no's, then you just have an argument that affirms the antecedent. So it is a modus ponens. It is an argument that affirms the antecedent. When you see two negatives, you just cross them out and you're left with a positive. All Europeans are my friends. Ben is a European. That affirms the antecedent. So it is an argument that affirms the antecedent. A modus ponens. So watch this video. I'm uploading it right away. Maybe if you watch it several times, the lessons will sink into you. And then, of course, I had already told you earlier that by now I'm hoping you have bought your textbooks. This is the most difficult topic in this semester. So if you don't get it right, you might not pass your exams. Even if you didn't attend the class, you can understand it by reading the textbook. So I am suggesting you go and read your textbooks, do the exercises, watch this video, and I'm sure you'll pass. If you passed your WAEC, your SSC, and your GCE, then there is no excuse not to pass this class. I wish you the best of luck. Any questions?
So
If you have a question, you raise your hand, but don't unmute your mic until I tell you to ask. Nkrumah.
Hello, sir.
Yeah, Adams.
Hello.
Yeah, go ahead.
Hello, sir.
Go ahead, I'm hearing you. Sakina Adams.
Doctor, please, can I get a book today?
Of course, it's there every day. You know the philosophy department?
Philosophy and classics.
Yeah, there are two departments merged into one. So the philosophy section, it is directly opposite Legon Main Hall.
Okay, thank you.
Welcome. SK or Fori? SK or Fori? Equamen Nkrumah.
Say,
Yes.
when we consider the validity versus the soundness, are we looking at the fact that the two statements are like we are following the rules or we are following the reality of life?
If
Like the
you
example.
if you follow the rules, then if you follow the rules very well, then it is a valid argument. A valid argument is an argument that has followed the rules. But you can follow the rules and still tell lies.
Yes.
So
at the end,
you can say, for instance, let's give an
the
example.
mosquitoes and the reptiles.
Yes, but I want to give another one that is closer to us. So let's give an example with something in the country. So what do we say? Let me see.
All presidents are called John.
All presidents are court judges. Nanado is a president. Therefore, Nanado is a court judge. That's a valid argument. It is an argument that affirms the antecedent. The antecedent is all presidents. Now, when you look at two premises, an argument is normally Kennedy, why did you put on your mic? Okay, so when you look at an argument, you have two premises and a conclusion. That's for a class anyway. Arguments normally have more than two premises or even just a statement. Now, which of the premises do you normally divide into antecedents and consequence? When you say all presidents are court judges, Nanado is a president, therefore Nanado is a court judge. Automatically, you know which of the premises that is divided into antecedent and consequence. It is the all presidents are court judges. The other one, Nanado is a president. You can't divide it into antecedent and consequence. Nanado cannot be an antecedent, and the president cannot be a consequence. That particular statement is identifying Nanado as the antecedent. Yes, as a court judge. A premise that identifies something of something is not, that's not the one, that's not where you find your antecedent and consequence. The premise that is divisible into antecedent and consequence, I normally call it a major premise. So we have two premises. All presidents are court judges. Nanado is a president. If you look at the two premises, you know the one that is a major premise. The major premise is all presidents are court judges. That's the major premise. And then Nanado is a president. That's the premise that identifies a third party as either an antecedent or a consequence. So once you understand that, then you see how it operates. All presidents are court judges. Nanado is a president. Therefore, Nanado is a court judge. So it is valid. Nanado is a president is affirming the antecedent. So it is an argument, it's a modus ponens. An argument that affirms the antecedent is a modus ponens. It's a valid argument, but it is not true. And it is not true because there is a false information somewhere. The false information is in the major premise. All presidents are court judges. That false information entered the conclusion.
Thank you.
Yes, so in real life, you can encounter people who make valid arguments that are not true. There are a lot of valid arguments that are not true around us. We are supposed to be identifying such arguments as logicians.
Yeah, blue.
Okay, so I guess now we have homework to do. You can now go to start reading up this topic. I expect all of you to go through it again so that you understand it better. Okay. So I wish you the best for the rest of the day.
No, sir.
Thank you. You too.
Bye-bye.
All right.